Swayam Prabha. Digital India. Educated India.
Welcome you to the next class on Inorganic Chemistry of Life, Principles and Perspectives. During all these previous classes, we have looked at a variety of introductory aspects, followed by a huge number of enzymes based on different metal ions like transition metal ions, transport in case of the alkaline earth like ATPases etc., and enzymes based on the manganese, enzymes based on vanadium, iron, of course, cobalt, nickel, copper, zinc, molybdenum. Then we looked at the mercury reductase, selenium enzymes. So, we have more or less covered a huge variety of enzyme based biological inorganic chemistry, which is pertinent to the life. A few more aspects are required to give a feel of inorganic chemistry into other aspects of life, and these are as follows. Inorganic compounds, not only inorganic compounds are not only a part of the enzyme, as I said initially, the inorganic ion center plus the protein. Then inorganic ion center I talked to you as a primary coordination as a complex. So, it is like an inorganic complex suspended in a protein. Now, we can take such inorganic compounds or simple inorganic compounds. These have found a great importance in medicine. Inorganic compounds, see this particular slide, based on silver, based on arsenic, which we think it is a poison, based on gold, based on vanadium, based on chromium, cobalt, mercury, iodine, magnesium, platinum, ruthenium, titanium etc., zinc, tungsten, gadolinium. A variety of these things, their compounds can be used in variety of aspects, like it could be antibacterial, antimicrobial, anti-diabetic, anti-arthritis, anti-acid, anti-cancer, antiviral, anti-HIV, variety of these things. Also can be used towards the contrast agents etc. So, therefore, inorganic ions are widely spread as their compounds and complexes and salts in medicine. So, let us look at little bit more detail into this one. As we keep going through this particular slide, we understand a lot of features. Okay, so, we were trying to look at this particular table where we have the inorganic compounds. Let us look at silver. Silver in the form of silver sulfur design is antibacterial, and I am sure you would have seen on some of the antibacterial drugs on the bottle, you would see also the compounds that you have. Aluminum, aluminum is in the aluminum hydroxide, and you know that aluminum hydroxide, this is used absolutely as the antacid. Sometimes some of the cases even silicate based also people use, and the aluminum hydroxide. Arsenic compounds of various things, these are all commercial names, they can be used in the antimicrobial too. Gold thiolates, gold as just we will be looking at the heavy atoms. Gold is also one of the heavy atom and is a soft ion. So, therefore, it can bind with the thiolates much better. So, gold 1 thiolates, auronophin, AU1 diphosphine complexes, all of these can be used in anti-tumor, anti-arthritic. So, basically anti-arthritic and then antiviral. So, gold compounds are also used a lot on the kind of compounds you can see here. Bismuth salicylate, bismuth colloidal, bismuth citrate, all of these can be used also as an anti-ulcer as well as antacid. That is not the list completion, we have a lot more. Let us look at this particular slide also. Barium, you know the barium in the form of barium sulphate. Where do you know the barium sulphate? and people who are having some kind of a intestinal ulcer, in the hospitals the doctor will recommend you to get the X-ray contrast picture. For that they ask you to take the barium sulphate solution. After you drink barium sulphate solution, and then the X-ray is taken, and from that you can get the where the ulcer is there in the intestines. Okay. This is also known as a barium meal test in the general context, because they give you to drink the barium sulphate solution. So, therefore, it is called barium meal test. Okay, bromide in the form of sodium bromide is a sedative. Chromium complexes not proven very well, but they are in the anti-diabetic side. Copper of course is a histidine complex. It is supplement for Menkes disease and for various things of that kind too. Cobalt is coenzyme B12. It is a supplement we take whenever we feel weak, we always take that. Iron, sodium nitroprusside, iron desferrioxamine chelates, all of these are as vasodilators. So, the dilators is that vesicular dilators, because the blood thinness, if there are some kind of the blood has got some kind of materials of non-insoluble kind of things, etc. Those kind of things can block the vesicles. So, these things can be sort of cleared out by using such kind of things. Of course, people use even NO also for that as a dilator too. Gadolinium complexes are very good MRI contrast agents, and some of them may also be used in the PDT, antimicrobial, etc. So, mercurochrome antiseptic, and as iodine, we all know that iodine tincture, iodine we call it as, use that for as antiseptic. Lithium carbonate for manic depression. Lutetium complexes as the photodynamic therapy. PDT means photodynamic therapy. Magnesium as magnesium oxide, magnesium hydroxide kind of things, not necessarily oxide. These are antacid laxatives also. They give certain times when you complain that you have a problem for motion, then the doctor will recommend you to take the laxatives. Manganese supplements, manganese complexes, these can be as an antioxidant, and manganese can also be used as MRI. Still we have many more compounds, for example platinum. So, the platinum complex, which is a popular platinum complex, it is a cis-platin, everyone knows as an anti-cancer agent. Ruthenium complexes, a lot of things, I will show you later these complexes too, they are anti-cancer. Antimony, okay. So, N-methyl glucosamine antimonate, anti-leishmanial kind of activities. Aluminum, aluminum silicates, anti-diarrheal, and tin ethyl etiopurpurin is a photodynamic. Technetium again has a half life kind of thing. So, therefore, that is also used for tracking, diagnosing, imaging. Okay, titanium dichloride anti-cancer, these are proven but not used. Not all of them have been commercially used, some of them are well proven, but many of them are well used also. Vanadium. So, you have some maltolato oxovanadium, glycinato oxovanadium, these have shown anti-diabetic activity, but not been continuously used. Then the polyoxometalates, anti-HIV activity. Zinc oxide, zinc bicyclam complexes, they are all like skin ointment, antiviral, etc. Zirconium, the glycinato, antiperspirant. Selenium, we have seen recently that the epsilon is the commercial kind of thing. Selenozofurin, selenotifen. What are these? These are antioxidant. So, therefore, antioxidant antidotes. So, antiviral, antioxidant, anti-allergic thing that you use. So, we have seen a number of cases, as you see from here, these are all given alphabetical order: silver, aluminum, arsenic, gold, bismuth, barium, bromine, chromium, copper, cobalt, iron, gadolinium, mercury, iodine, lithium, lutetium, magnesium, manganese, platinum, ruthenium, antimony, silicon, tin, technetium, and titanium, vanadium, tungsten, zinc, zirconium, selenium. Every one of these, now you can you appreciate that a number of inorganic element based salts, complexes, compounds, they are involved in variety of as drugs in variety of diseases. Now, let us look at some of the structures of these ones. Now, in this slide I have tried to show some compounds of inorganic complexes as drugs for different diseases. One of the thing here you see is the gastrointestinal problems. It is very common, gastrointestinal. So, this is what is a manganese, and this is what dichloride. So, manganese 2, and this is the kind of a cyclum type complex covered. This is a kind of it is a cyclic ligand with the manganese. Here you have gastrointestinal bismuth hydroxide, but bismuth hydroxide is coupled with this kind of a chelate. So, that you have only one hydroxy group. So, these are used in the gastrointestinal problems. Vanadium, you can see that this compound here and the other compound here with some difference. This is the methyl part, this is the ethyl part, only the difference is that methyl ethyl derivative. These are used as anti-diabetic compounds. See some things here. So, what do you see here? There is a nitrogen, there is a hydroxyl 1, 2, 3, 4. If you have a metal, it will become 5 membered. So, these can act like a chelate, and here again 5 membered chelate. So, you have a metal chelators for chelating some ions, ions like zinc, ions like copper, etc. That is why they can act in Alzheimer's disease, because in the Alzheimer's disease the active ions are zinc and copper. So, these ions can be chelated and removed kind of things. Let us look at some more. Okay, here we have some things like antimicrobial, anti-parasitic drugs. So, this is the melarsoprol. So, where you have what do you have? Arsenic, and it is a kind of a dithiol bridge binding chelation. Okay, and this is organoarsenic kind of a compound with the thiol. So, organoarsenic thiol based compound, this is what is called melarsoprol. Okay. And here you have another compound which is antimony based. So, this is meglumine antimonolate. So, this is the antimonic part, and this is the other organic part which is bound together will form a drug, a complex for the drug. So, for the antimicrobial, etc. Here is another case where sodium stilbate, this stilbium, stilbuglucose, this part is the glucose, this part is the antimony which is called stilbate and sodium, and this is also is there as a antimicrobial kind of thing. Now, you have some more compounds here, bismuth based compounds, silver based compounds, and iron based compounds. This is basically what you see here, ferrocene. So, ferrocene based compounds with some additional quinoline moiety kind of a thing, additional quinoline kind of moiety. This is so, these some of these are in clinical trials. So, these are used antimicrobial, antiparasitic, some of them too. So, do you appreciate and understand how varied the inorganic medicinal aspects are? Okay, then let us look at some anti-cancer activity drugs. There are a lot on the platinum, I will come to that in a while. Let us look at, before going to platinum, ruthenium based. Now, these are not much into the market, but they are shown at the laboratory level, not at the commercial kind of a level. So, these are all ruthenium based. You see that ruthenium based. So, kind of an anion. So, you have a counter cation, imidazolium, ruthenium 3, 4 chlorides, etc., etc. Again, instead of imidazolium, benzimidazolium kind of a thing, diazole kind of thing, cation, or you can have sodium. So, these two are same, but the counter cation is different, and this itself is different. So, we have different kinds of anti-cancer based agents which are shown to have a good potential anti-cancer activity, though they have not taken up to the level to bring it as a drug into the market. Some of them may be going through the trials. Okay, come to the major class of the anti-cancer drugs. We know very well used in most of the countries, and still underused in some countries too, are the platinum based drugs. So, cis-platin and carboplatin and oxaliplatin and strataplatin and nedaplatin and loboplatin and heptaplatin, see that all of them. So, they all have either the diammonia or diamine, you see diamine kind of a part, diamine part, diamine part, diamine part. This is a different compound, and this is a platinum 4 based one. Okay. So, all others are platinum 2 based compounds. So, this is 2 minus, so therefore 0, 2 minus 0, 2 minus 0, 2 minus 0, also all of these neutral. So, because nitrogen ligands being neutral. So, in fact, cisplatin has been very well used, even carboplatin has also been used in many other cases too. So, therefore, you can see that a lot. Of course, nowadays people have started using the platinum 4, so that the in situ it will be reduced to platinum 2, and then the further release of the things, and then also add some adjuvants to arrest the side reactions. So, in order to arrest the side reactions, then people have started using adjuvants also binding to them. Okay, we know the cisplatin, this is the cisplatin, and we know there is the structural analog to this is called the transplatin. So, these are the trans groups. So, its composition is exactly the same. So, one would expect that if the cisplatin works for cancer, transplatin should also work, but it is not true. Only cisplatin works and transplatin does not work. So, it is not that simple, okay? And the cisplatin itself is a boon to cancer patients. Invention of this, as you know, initially it was a serendipitous the exploration when electrochemical work being conducted by Barnett Rosenberg, he could recognize there are certain kinds of things are developed at the center, at the platinum center, and then finally found the compound being the platinum diamine dichloro thing. And so, that is where, that is how this has come, and later on certain developments were made in Lippert's group at MIT as well. Okay. So, it is only the cisplatin which works, not there. So, this means the it is not only just the inorganic compound, its geometry, its coordination properties, its redox properties, all of these are important. In this case, it is the geometry which is important. Cisplatin is shown over there. Okay. Now, how does it do? Cisplatin? Cisplatin has got this the 2 chlorides here, and these 2 chlorides get ionized in the bloodstream in the cell and converted by water ligands, and this is being attacked at the guanine rich region, where the N7 of the guanine will bind, N7 of another guanine will bind here, displacing the 2 water molecules, prior to that chlorides. And why not trans? Trans cannot form intra-strand, it can form inter-strand because there are 2 chlorides on both sides. But the thing is that it is not the reason that it cannot bind like this, it can bind inter DNA cross strands, but the inter DNA cross strands can be repaired very easily by the repair enzymes, whereas the intra cross strand, this one which is formed by the cisplatin, cannot be easily repairable. It is the main reason is this one, the repair enzymes are not functional In one case, the repair enzymes are functional in the trans-platin case. Therefore, trans-platin is not effective, cis-platin is effective. Not that trans-platin cannot make a complex with the DNA. Trans-platin can also make a complex with the DNA, just like the cis-platin can make, but a different type of complex. And that different type of complex can be easily repaired, whereas the cis-platin cannot be repaired. And that is what I have explained over there. So, you can look into that. Okay, so, what are we trying to look at? We are trying to look at how does this function. Let us look at some features of the mechanism of the cancer cell apoptosis. Apoptosis is cell programmed death of the cells, and I will come into details in one other lecture. Fully I will take on the aspects of apoptosis, what kind of inorganic complexes are involved in apoptosis of cancer cells. So, I will take in future classes 1 or 2 classes on that, covering on that too. At least one class covering that kind of a phenomena and what kind of compounds in the future. Now, for the time being, let us look at the mechanism of action of the cis-platin. I already mentioned to you, cis-platin binds to the DNA in an intra-strand fashion, whereas trans-platin interstrand fashion. There are always repair enzymes. The repair enzymes can definitely repair the trans-platin adducts, but not the cis-platin adducts. Now, let us take the cis-platin. When it enters in, the dichloro part will get hydrolyzed to 1 chloro with 1 water, both the waters, etc. And this can further, or you can have some other kind of a donors, 1 chloride, 1 donor, this getting into the DNA and forms the kind of a bond you see here. It's a bond here. Okay. So, this is the kind of things that you have of these ones, and these are coming from the guanine nitrogen to bind to this. So, if they are bound intra-type, and then this will be taken by Gogli and the platinum is extruded. So, repair enzymes can act, but repair enzymes cannot act on a cis-platin, but repair enzymes can act on a trans-platin. As I said earlier, it is this kind of a thing which is basically making a difference. Now, can you understand the cis-platin versus trans-platin? Composition is same, just the geometry. In one case, the chlorides are cis or amines are cis, or in the other case, the chloride or ammonia are trans. So, that is what we are looking at. So, trans will form trans like interstrand products, and cis will make intrastrand products, and the enzyme can repair the interstrand products, but not intrastrand product. So, what does this tell basically? So, just one example that I have explained you, and we will see the apoptosis, maybe some more examples in the future classes. And let us look at overall how does one design an inorganic drug. So, to design an inorganic drug, you choose a metal ion, you choose an oxidation state, you choose a coordinating ligands, you choose a coordination geometry, many of these things. So, it does not mean that all the ligands have to be same. Since I have put as Ln, please do not take that all these are the same ligands. It can be same ligands, it can be different ligands, or it can be 2-3 different ligands, etc. All of these are possible. It need not be octahedral, it can be tetrahedral, it can be square planar, it can be linear, it can be trigonal bipyramidal, any kind of geometry, and number of ligands accordingly. So, there is no fixed like that. So, that means you have a plethora of possibilities of an inorganic complex can be made. So, when you make such complexes, you also have parallelly their isomerism playing a role. It could be structural isomerism, geometrical isomerism, the optical isomerism, various kinds of isomerisms also there. So, some of these isomers may not be active, some of the isomers may be active, just like we have seen the example of cis-platin is active, trans-platin is not active. So, that means one once you plan a design, you make a lot of complexes. These complexes can be checked with for their activity. Some of them bind, some of them may not bind. Some of them will bind and react, some of them may not bind, may bind but not react. All of these things are possible. So, it all depends on basically on the coordination chemistry principles. Coordination chemistry principles are what? Coordinating ligands, their number, the type, nature, chelation, non-chelation. So, the macrocyclic effect, chelate effect, all these kinds of things. Then geometries, the 2, 3, 4, 5, 6 and mostly 4, 5 and 6 are very common for transition metal. Occasionally it could be 7 and sometimes you can have 2 and 3 also. So, all of these so many things that you have. There is a huge level of inorganic chemistry design is possible and so many different metal ions are there, so many different oxidation states are there. So, it is as wide as the organic drugs, where the people do derivatization on the aromatic rings, derivatization using nitrogen ligands, phosphorus ligands, sulfur ligands, oxygen ligands, etc. Similarly, you can complex with various kinds of ligands. Ligands can also be active, maybe you can use non-active ligands, active ligands, all of these is possible. Thus, you can have a plethora of inorganic complexes. We cannot call all of them as drugs, only those which show activity on some enzymes, on some cells, on some tissues, on some organs, etc. So, those things we can call it as drugs, and all other things are simple, the inorganic compounds, inorganic complexes. So, then this complex or compound or drug, what you say, should interact selectively with some biomolecules, not every. That means with some enzymes, but not with every enzyme, if you take. Because if it binds to every enzyme, unwanted things happen. This is what we refer in the medical thing as the side effects. So, there are a large number of drugs which are very good, very effective on the disease, but they are bad because they show a lot of side effects. That is why always there is the design, new improvement of the inorganic complexes, inorganic drugs keeps on going on in order to reduce the side effect, in order to increase the potential, in order to increase the selectivity, so that it will not attack all the molecules, all the kinds of cells in the body, but they will attack selectively only certain molecules and certain ions, certain molecules and certain cells, etc. So, the complex should interact selectively with biomolecules either through outer sphere or through inner sphere binding mechanism of all this. So, what have we looked at so far? We have looked at a very large number of inorganic ions are important, not only as the metalloenzymes, but as drugs. Their salts, their complexes we have seen almost A to Z. They are involved in some activities like anti-diabetic, anti-cancer, anti-arthritis, so anti-bacterial, anti-fungal or what not, anti-HIV, all kinds of activities. So, all these kinds of activities are shown by this. So, therefore, there is a huge future for developing inorganic drugs based on the metal ion complexes. Complexes can be neutral, complexes can be ionic, ligand need not be same, ligand can be same, ligand can be different, and geometries can be varying, etc., etc. So, therefore, a huge amount of inorganic chemistry things. And as I said, I will discuss the apoptosis programmed cell death in the future class. Thank you very much.